Assalamualaikum, we're from Group 4 presenting for neuropathy system in diabetes. My name is Nur Alaimanina and my other members Yumin Arifa and Nazmi bin Jasmi. Introduction. Computational intelligence, artificial intelligence and soft computing techniques such as artificial neural network, fuzzy logic, evolutionary algorithm and smart intelligence have been widely applied to medical diagnosis, prognosis, and predicting any any disease. Diabetes is a metabolic condition marked by hyperglycemia caused by ab- abnormalities in insulin secretion, insulin action, or both. Type 1 diabetes is defined by shortage of insulin, while type 2 diabetes is defined by inability to use the insulin produced by the body. Artificial neural network and fuzzy logic were used to diagnose diabetes in ANFIS as well as Gaussian kernel methodologies to predict type 2 diabetes prognosis. TB was detected using a fuzzy-based decision support system. Risk assessment of cardiovascular disease was performed using a web-based fuzzy system combined neural network and fuzzy logic to diagnose hypertension. That's all from me. I will pass to my other members.
Okay, so for the methodology, is adaptive neurophagy system. There is five consists of layer, and each layer has its own process. In the layer one, the first layer is falsification, and each node has a membership function, AI and BI, with the layers output being as follows, like show in the screen. And for the layer 2, the product layer is a second layer. These layers neuron are non-adaptive and compute the product of incoming signals. The firing strength of a rule is generated by each node. In layer 3, the normalizing layer is the third layer. The nodes in this layer are non-adaptive and compute the normalized firing strength, which is the ratio of a rule firing strength to the sum of a rules firing the strength. So for the layer 4, the next stage is for each node to build a function after receiving the normalized power from layer 3. And for the layer 5, the single node in this layer is fixed label in the end-phase architecture in figure 1 above the symbol F, which calculates the entire output of the signals firing from layer 1 to 4 and can be expressed mathematically as it shows.
For the result, an adaptive neurophagy system was used to determine the blood glucose level of diabetes patients. Data were used to train and test the system's performance, and a hybrid learning method was used. Figure 2 depicts the result of generating an ANFIS structure based on this data. Okay, the structure is derived from six inputs with two linguistic terms in some inputs and three linguistic terms in others. And the rules are generated by ANFIS was a target output of 1. Okay, next. Okay, this is a rule viewer. Graphic 3 depicts a fuzzy logic control known as a rule uh, now as a rule viewers. The yellow color in the figure represents the patient's symptoms, while the blue color represent the diagnosis. Next. Okay, this is a validation performance, the result of the diagnosis. Next. Okay, the conclusions. uh, ANFIS was used to implement a diabetic diagnosis system in which 70 data points were used for both training and testing. The error obtained is 0.008333 during training, testing, and validation. In medical diagnostics, the performance of this system and error obtained are acceptable. That's all from me. Thank you.